Earth's moon is far from being a been-there-done-that world, notwithstanding a dozen Apollo short-stay visitors between 1969 and 1972. Today, our celestial neighbor could serve as a homeland for a bevy of scientific and commercial interests, from cranking out made-on-the-moon oxygen and fuels to installing antennas that scan the heavens for signs of other technological civilizations. Lunar research can even surrender basic clues about the formation of our solar system and Earth itself. So, let's talk about it. Welcome to Space World. In today's video, we are going to talk about how NASA's Artemis program is aiming for lunar sustainability. So if you want to know more about it, then stay with us until the end of the video. NASA's Artemis program to reboot the moon, or at least human activity there, is to utilize innovative technologies so that Artemis moonwalkers can explore more of the lunar surface than ever before and forge the first long-term presence on the moon. However, a 21st century human return to that world to perform sustained or perhaps even permanent moon operations would not be trouble-free. In many ways, NASA's forward-looking vision is caught between a moon rock and a hard place, having to first develop the technologies required to give crews the wherewithal for longer and more sustainable operations on the lunar surface. So, what does sustainable mean? NASA is getting its lunar act together by first mustering up what's needed for early human exploration of the moon via the Artemis program. The agency will later attempt to harness the technologies and skills necessary for a sustainable live-off-the-land approach for a lunar base. Oddly, the meaning of the term sustainable seems to be up for grabs. For instance, the April release of the U.S. National Academy's Planetary Science and Astrobiology Decadal Survey 2023 through 2032 noted that NASA has used the word to describe only one goal for human lunar exploration under the auspices of Artemis. As sustainable has not yet explicitly been defined in this context, the report states a working definition was crafted to mean that there are widely accepted reasons to continue human lunar exploration that justify the continued investment, commitment, and risk beyond a few missions. That said, it's always a good move to ask advice from a person who has actually explored the moon. According to Jack Schmitt, an Apollo 17 moonwalker, sustainability in terms of a future moon settlement has less to do with finding useful resources on the lunar surface and more to do with lowering the costs of launching crew and equipment. The geological understanding of lunar resources and the technological foundations for sustained settlement of the moon are either in hand or well understood, Schmitt stated. He also added that the primary remaining challenge consists of having a reliable, heavy-lift booster in the class of the Saturn V or larger that will put both economical cost and achievable risk management within reach of private or national entities. Apart from this, Ben Busey, who is an APL planetary scientist, is leading the team supporting the NASA Space Technology Mission Directorate's Lunar Surface Innovation Initiative. Our job is a systems integration role, Busey said. What capabilities does NASA need for a sustained human presence on the moon? And how do you make sure that these are the most efficient and best technologies being developed? In addition, Busey emphasized that NASA is working with a number of American companies to deliver science and technology payloads to the moon's surface through its Commercial Lunar Payload Services (CLPS) initiative. It's all about rapid technology development. With the help of CLPS, every lunar opportunity is precious. We're essentially an independent evaluator about getting key technologies onto the lunar surface. The idea is that we provide to the government neutral advice and guidance, and that includes community liaison. So taking a futuristic look at an Artemis base camp, Busey likens it to McMurdo Station, the largest complex in Antarctica. McMurdo was established in December 1955 and is the logistics hub of the U.S. Antarctic program run under the National Science Foundation. Research in multiple fields is performed at and near McMurdo Station, including astrophysics, geospace sciences, and atmospheric sciences. The infrastructure associated with McMurdo enables scientific exploration for the entire Antarctic plateau, something that would happen a lot less if each individual expedition had to fly everything in and out of New Zealand or South America. Similarly, I hope the lunar base camp will allow exploration of the entire moon, Busey added. Adding to all this, testing moon-bound equipment is also a necessary part of this mission, because matching the appropriate simulated lunar materials for testing new technologies here on Earth prior to shipping them off to the moon is important. These include mineral chemical simulants for appraising equipment that, for example, can produce oxygen from the moon's topside regolith, and also mechanical simulants to judge mobility, excavation, and construction ideas. Both lower and higher fidelities of simulated lunar materials are indispensable in judging technology readiness levels of moon-bound equipment, especially when getting into 3D printing of regolith or the sintering and extruding of simulated materials. Knowing the melting temperature by well-matched, fine-tuned simulants is hugely important. Therefore, just using any off-the-shelf simulant to study how equipment and processes react on the moon is not prudent. According to researchers, there's a lot of effort to try and understand what technology can be adequately tested on Earth in facilities that exist or others that could reasonably be developed. In that testing queue are aircrafts capable of simulating the moon's 1/6 gravity for brief stints during parabolic roller coaster-like jaunts, making it feasible to flight test equipment intended for moon use. So, what are some of the other resources that humanity would need to turn Moon into a sustainable place? While researchers admit that water ice on the Moon draws a lot of attention, that's not the number one resource at the lunar South Pole. That would be sunlight. According to the research done, there are hilltops in that South Pole region that are nearly continuously bathed in sunlight for around 250 days out of the year, a situation ideal for the emplacement of a cluster of solar panels for power generation. As for lunar water ice, you can't design mining gear very straightforwardly if you don't know the distribution and quality of that water ice. So, how deep is it? Is it in solid blocks or tiny ice grains? You need to know the status of that ice before you can confidently make technology to go mine it. That's a piece of the puzzle, a tall tent pole. Unfortunately, there's limited data that dives into clarifying that water ice riddle. And this is the exact type of knowledge gap that needs to be closed, experts say. To do so, it would be necessary to send lunar orbiting spacecraft with special instruments that can sense the whereabouts, quantities, and conditions of water ice on the moon. They'll need to fly over territory at low altitude in barnstorming fashion, Runyon suggested, followed by robotic rovers to localize that water ice down to football field-sized grids. Then we can confidently design the technology for extracting the water ice, and we need to do that as soon as possible. And this is it for today, guys. What are your thoughts on today's video? Share your views with us in the comments below. Also, don't forget to give this video a thumbs up, subscribe to the channel, and ring the bell icon for more amazing videos about space. And thank you for watching.